professor in LJIT. Welcome to session of Theodolite surveying. This is the first session or first video of Theodolite surveying. In this video, I have explained about what is a theodolite, what is a theodolite surveying, use of theodolite, classification, and essential part of or component or elements of theodolite. So, first, going the further, first you know that the different type of survey you already studied on a BCE, basic civil engineering, like compass survey, chain survey, tape survey. In a compass survey, you measuring the horizontal angle and respect to meridian, which is less accurate, and also it is not possible to measure the vertical angle with the compass. So is a disadvantage or limitation of compass. Now going the further, the bigger work, bigger side, uh, instrument to be changed, method to be changed, because here the larger work are doing, so that compass is not working in this type of condition, field condition. So theodolite are used for finding the horizontal angle as well as the vertical angle on the field. So you know that measuring the horizontal angle using the compass with respect to meridian, which is less accurate, because these are some reference we have taken is a meridian, so it is not possible to the accurate horizontal angle and not possible to measure the vertical angle. So here, when the object are as a considerable distance or situated at the considerable elevation or depression, it becomes necessary to measure the horizontal angle and vertical angle more precisely, because some point are below the ground or below the horizontal plane and some point are above the horizontal plane. So angle of elevation and angle of depression to be find is a necessary, and as well as the horizontal angle are more necessary to be find, more necessary on a field. So theodolite, it is the instrument, this is the most precise instrument for finding the horizontal angle as well as the vertical angle. So measurement taken by the instrument is known as a theodolite. Here these are a horizontal angle, like example OAB means finding the angle of AOB, horizontal angle. Similar that vertical angle OAC and OBC. So these angles are measured precisely by using the theodolite. Now, student, you know that the system of surveying in which the angle are measured with the help of theodolite is called the theodolite survey. So, what is a theodolite surveying? This system of surveying in which the angle are measured with the help of theodolite. So, which are the method, which type of system are used to find out the horizontal angle, vertical angle? So I have explained all the detail in this chapter. So this system is called as the theodolite survey. In this system, the instrument have used for finding the horizontal and vertical angle is theodolite. Now the theodolite is the most precise instrument used for measurement of horizontal and vertical angle than other compared to the compass. So it is the most precise instrument compared to the compass. Now the theodolite is most accurate surveying instrument mainly used. So next topic is use of surveying. So use of theodolite in a surveying, measuring the horizontal and vertical angle. You know that I have already explained. Locating point on a line, on a site, there are 20 to 25 meters line. So on a line, locating the point. So the instrument are used is theodolite. Prolonging the survey line means extend the line. Finding the difference of level. So already use dumpy level, but here dumpy level is not necessary. Theodolite is used for finding the difference of level, setting out of grades, ranging curves, tachymetric surveying. So these are survey or these are application are doing with this instrument is called the theodolite. Now, this is the most important question is classification of theodolite. Here, classification of theodolite mainly classified two types. One is based on movement of telescope, and one is a classification based on arrangement. So there are two classification, and There other another classification depending upon the moment of telescope and arrangement based on arrangement. So one is a based on moment of telescope. One theodolite is called the transit theodolite, and one is non-transit theodolite. Similar that arrangement based on arrangement, there are three types: micrometer theodolite, vernier theodolite, and electronic theodolite. So these are a classification I have already explained in detail. So first classification based on movement of telescope is a transit and non-transit. So transit theodolite means a theodolite is called a transit when its telescope can be transited, revolved through a complete rotation about the horizontal axis. Carefully listen, horizontal axis in the vertical plane means the telescope can be transited through 180-degree and complete rotation about the in a horizontal axis in a vertical plane. So it's called a transit theodolite. A theodolite is said to be transit one then telescope can revolve through 180-degree in a vertical plane about its horizontal axis, thus directing the telescope in exactly opposite direction. Now, what is a non-transit theodolite? This telescope cannot be transited. Means here telescope is movement is no, not in a facility. So only taken the reading, not a movement of telescope. So this type of theodolite is called as a non-transit theodolite. Means cannot be transited. They are inferior in utility, means now become obsolete. So a major use of on a field nowadays is a transit theodolite. So these are transit theodolite. Here listen, see here telescope are movement. Here in something 30-degree to 40-degree to can rotate it in a 180-degree also. But here non-transit theodolite telescope cannot be transited. So these are a classification of theodolite based on movement of telescope. Now classification of theodolite based on arrangement. So you know that after the taking the observation or measuring the angle, last finally you note down the reading. So here these are a different type of theodolite available on a market. So one is the vernier theodolite, means here for a this in this type of theodolite for reading a graduated circle if vernier are used, means taken the reading from the vernier, so it's called the vernier theodolite. The vernier theodolite is the most important instrument or most used instrument nowadays. Second is a micrometer theodolite, where if micrometer is provided to the read the graduated circle, the same is called the micrometer theodolite. And last is the electronic theodolite. Nowadays, most important instrument means electronic theodolite plus electromagnetic distance measurement means a total station to be used. So here, as a screen with digits of four angle on front or back of the instrument. So here, the reading taken from some display, so is called the electronic theodolite. So these are three classification of theodolite based on arrangement. So I have repeat one thing. Theodolite may be classified as a movement of telescope and classification based on arrangement, transit and non-transit, micrometer, vernier and electronic. Student carefully listen, keep your mind. In this session, means in all the session of the theodolite, I focus on one theodolite is a transit vernier theodolite. Means classify based on moment, I have taken the transit, and based on arrangement, I have taken the vernier. So full name of the theodolite is transit vernier theodolite. So next, size of theodolite. This is the most important thing. What it means how the theodolite is designation. So a theodolite is designation by the diameter of the graduate circle on the lower plate. Means here these are a lower plate. The common size of lower means theodolite is 8 centimeter to 12 centimeter. Means here 8 centimeter to 12 centimeter. What is what is the value? It is the value of diameter of lower plate. So 8 centimeter to 12 centimeter while construction of small scale area like traversing, but when the geodetic surveying means triangulation work are doing, so uh, instrument are used 14 centimeter to 25 centimeter means bigger diameter instrument are used. So greater accuracy is achieved with the larger theodolite. as they have bigger graduated circle with a larger division as used with the high degree of accuracy. So here size of theodolite depending upon the lower plate diameter. So keep in mind, not a height of theodolite, not a width of theodolite, only theodolite are designation by the diameter of the lower plate. So next topic is essential part of one-year transit theodolite. So here I will already explain the theodolite are used on a field. Now means in this particular semester only focusing of the theodolite is one-year transit theodolite. So I have explained all the essential part of this theodolite. So there are number of essential part of one-year transit theodolite. I will explain in detail. First, remember all the name. One is a telescope, the vertical circle, the index frame, the standard A frame, leveling head, two splinter, the lower plate or scale plate, the upper plate or vernier plate, the plate level, tripod, the plumb bob, the compass, and standing level. So these are parts, essential parts of vernier, or these are elements of the vernier transit theodolite. Now I have explained detail one by one. So first essential part of vernier transit theodolite is triband. So here I will clearly seen in this image. This is a triband. Triband, it is the circular plate having a central threaded hole for fixing the theodolite on the tripod stand by a wing nut. It is also called as the base plate. So these are the base of the theodolite. So tripod are fixed, or theodolite are fixed on the tripod. So it's the most important part for taking the reading accurately. So trived is a circular plate having a central threaded hole, and use of trived is theodolite on a tripod stand by a wing nut. So this is the most essential part of or base of the theodolite. Next is a foot screw. So these are meant for leveling the instrument. Here there are three foot screw in a one-year transit theodolite. Foot screw are mainly used for the leveling the instrument. So it's the most is essential part of the whole the theodolite. So the lower part of the foot screw are secure in the trived by means of ball and socket arrangement, and the upper threaded part passes through the threaded hole on the tri-branch plate. So foot screw is the most important essential part of the vernier transit theodolite for leveling the instrument. Next is a tri-branch. It is the triangulation plate carrying 3 foot screw at its end. Means here carrying tie branch are carrying a 3 foot screw at its end. So these are the three important essential part on this slide. Now next, leveling head. Here this is a leveling head. The trived foot screw and the tie branch constitute a body which is known as the leveling head. Means there are, you know that the trived foot screw and tie branch are already explained in previous slide. So constitute a body which is known as the leveling head. Leveling head are seen, the instrument is level, yes or not. Now splinter. The theodolite consists of two splinter or axis, is also called as a axis. One inner axis and one is a outer axis. Here is a inner splinter, outer splinter. Inner axis is solid here and conical shape, and outer is a hollow. So these are essential part, leveling head and splinter. Now this is the most important essential part for finding the horizontal angle and vertical angle. After the using the foot screw means leveling, after the using the foot screw means leveling done, then work of essential part is lower plate and upper plate. Lower clamp screw, lower tension screw, upper clamp screw, or upper tension screw. So lower plate, or is also known as the scale plate. The lower plane is attached to the outer axis, and it is known as the scale plate. It is a beveled and the scale is graduated 0 to 360 degree. So this is a consist or attached with the outer axis, and is graduated means here is reading on a lower plate or scale plate is 0 to 360 degree. Now upper plate. The upper plate contains the vernier scale A and B. It is attached to the inner axis. Its motion is controlled by the upper clamp screw and the upper tension screw. So upper plate motion is controlled by the upper clamp screw and upper tension screw. Similar that lower plate motion controlled by the lower plate screw or lower clamp screw or and lower tension screw. So here carefully listen, lower plate are attached in the outer axis and the upper plate attached to the inner axis. When the clamp screw is tight means upper clamp and lower clamp vernier scale are fixed means two screw upper clamp screw and lower clamp screw both tight, so vernier scale are fixed with the inner axis, and for the fine adjustment of the scale the tension screw is rotated. So when the two screw tight means upper clamp screw and lower clamp screw. So theodolite is not movement on a any side, but only tension screw are used for find the adjustment to the scale uh, while taking the reading. While taking the reading. Now, essential part of vernier transit theodolite is a standard or A-frame, means two frame are provided, the upper plate to support the telescope here, A frame here support the telescope, these are a telescope, and two frames, one frame is one frame and second frame are provided on the upper plate to support the telescope, the vertical circle and the vernier scale, means here vertical circle and vertical scale. This frame is known as the standard A frame because these are shaped on a A. So is called a standard A frame. Now plate level. Here I have already seen it arrow. Here plate level. So upper plate carries two plate levels placed as a right angle to each other. One of the plate bubble is kept parallel to the vernier axis. Plate level can be centered with the help of the foot screw. So plate level are uh, leveling or centering with using the foot screw. Next is a telescope. You know that the theodolite is the optical distance measurement method. Means when the optics are used, so is called the telescope. Are used for bisecting the or establish the line of sight. So the telescope is pivoted between the standard at right angle to the horizontal axis. It can be rotated about its horizontal axis in a vertical plane. The telescope is provided with the focusing screw, clamping screw and tension screw. So there are three screw are provided because completely focusing of the object. So one is a focusing screw, one is a clamping screw means fit the telescope, and tension screw for finding fine adjustment. So these are all about the telescope. Next is a vertical circle. Now, here you know that I have explained about 1 minute. Uh, In a lower plate, you know that the graduated reading is 0 to 360 degree, but in a vertical circle, the vertical circle is rigidly fixed with the telescope and move with it. Means the telescope and vertical circle both are fixed. So when telescope are movement, vertical circle also movement, and is divided into four quadrant, which each quadrant is graduated from 0 to 90 degree in opposite direction with the 0 mark at the end of the horizontal diameter of the vertical circle. Means here the vertical circle graduated from 0 to 90 degree in opposite direction. There are four quadrant, means the vertical circle is 360 degree but in divided into four quadrant. So this all about the essential part: standard A frame, plate level, telescope and vertical circle. Last three: altitude bubble. A long sensitivity tube is provided on the top of the index bar. This bubble is brought to center by the clip screw and the timing of measurement of the vertical angle. Leveling head are used for finding the horizontal angle. but altitude bubble is used for when the or while the reading while the taken the reading on vertical angle, then altitude bubble always in level. So doing this leveling work, the clip screw are used when the measuring the vertical angle. So altitude bubble is most essential part for finding the vertical angle. Compass. Here, sometimes circular box compass is mounted on the vertical scale. Between the standard, in a modern theodolite, an adjustment through compass or tabular compass can be fitted with the screw to the standard. First, before the finding the non-transit theodolite, the compass are added on default added in the vertical vernier transit theodolite because for finding the north line respect to angle find the north line, the compass is used. So that in a vernier transit theodolite, sometimes circular box compass is mounted on the vernier scale between the standard. So these uh, compass are fitted in a modern theodolite or modern adjustment of theodolite. And last is the index bar. The index bar is provided on the standard in front of the vertical circle. It carries the vernier C and D at the two ends of the horizontal arm. For finding the horizontal angle, there are two vernier are used A and B, but in a while the taking the vertical angle, C and D vernier are used. So it is carry a index bar or T frame. So in this video, I have explained about what is the theodolite, what is the theodolite surveying, what are the use of theodolite, classification of theodolite, and essential part of theodolite. So thank you so much watching this video.